Hello, dear, welcome to the class. We're going to look on Bernoulli distribution, where the experiment is only two possible outcomes, success or failure. Success is denoted by P, and failure is denoted by 1 minus P or Q. So, the PDF of Bernoulli distribution, PDF is given by xp is equal to p raised to x q 1 minus x, where x is 0 and 1, 0 otherwise. So you can once determine M.G.F, mean and variance. So, solution. Let's start by finding the M.G.F of Bernoulli distribution. M.G.F is given by mxt is equal to summation of all x exponential dx times probability function. Summation of all x because this x is discrete. So, it's going to be x starts from 0 to 1 exponential dx. So our probability function is px q 1 minus x. So next step, where there is x, we're going to put 0. So it's going to be 0 times t, which is 0, p raised to 0, q. 1 minus 0 is q. We are going to remain with 1, so it's 1. Next step, we are going to replace y with the x with 1. So it's going to be 1 times t, which is exponential t, p raised to 1, q. 1 minus 1 is 0. So any number raised to 0 is 1. So it's going to be 1 times q. So it's here it will be q plus, here it's 1, p and q. So it's going to be p exponential t. And this is our M.G.F. M.G.F of Bernoulli distribution. Let's go to mean. Mean of Bernoulli distribution. First, we're going to look on first derivative of M.G.F, which is q plus p.et. So it's going to be d over dt q plus d over dt p et. So derivative of q is 0. We add. So we are going to use product rule, where it will be p d over dt exponential t, then et d over dt derivative of p. It's going to be 0 plus derivative of exponential t is exponential t. So it's going to be exponential t times p, which is p exponential t plus derivative of p is 0. 0 times exponential t is 0. So it's going to be 0. Here it's going to be p e t. So next step, it will be where x is 0, where t, not x, where t is at point where t is 0. So it's going to be p exponential raised to 0, where t is 0. So any number raised to 0 is 1. So it's going to be 1 times p, which is p. This is going to be the mean of Bernoulli distribution. Let's go to look on variance of Bernoulli distribution. Variance x is given by first derivative at t is equal to 0 minus second derivative at t is equal to 0 minus first derivative at t is equal to 0 but under square, or it can be mean. So let's first start by finding the first derivative. of, this is going to be the first derivative, so it's going to be d over dt of p exponential t. We already find that the derivative of PET is going to be PET. So our second derivative at t is equal to 0 is going to be p raised to 0 at t is equal to 0. So it's going to be p. This is our second derivative. So it's going to be variance. It's going to be second derivative, which is p. Subtract. First derivative was p. So it's going to be p under square. So it's going to be p minus p squared, which is, if you factorize out, it's going to be p into 1 minus p. But you remember, 1 minus p is the same as q. So our variance is going to be pq. Variance of Bernoulli distribution. Thank you for watching.